In the last video, we introduced the quantity molar mass, which is the mass of a mole in grams. For solids, molar mass is a highly useful and convenient quantity. What it allows us to do is measure out a solid, determine its mass in grams, and use that to determine the number of moles of that solid that we have directly. For liquids, molar mass is a little bit less convenient, and to help illustrate that, I wanted to show you a bottle of methanol, CH3OH. This substance is a pure liquid. There's no water in here. It's only CH3OH molecules. And while we could certainly weigh this out on a balance, that's a little bit inconvenient to do and can get a little messy because it's a liquid. What might be easier is measuring out a known volume of this liquid using something like a pipette. And in that case, we would need, if we wanted to know the number of molecules in that volume that we, for example, dispensed using a pipette, we'd need to know how many moles there are in a fixed volume of the substance. Or conversely, how much volume a mole of the substance takes up. Right? This is what's known as molar volume. In this video, we're going to take a look at molar volume and other molar quantities at the scale of 1 mole, and take a quick look at density or mass density, which allows us to relate the mass and volume of a pure substance. So we're going to define mass density and molar volume here, and then apply them in some basic calculations. Let's start with density or mass density. We typically refer to mass density just as density. There are other types of densities though, so you may hear the term mass density used specifically for the ratio of the mass of a pure substance per unit volume. Density is mass per unit volume. Units are something like grams per milliliter, grams being the mass, milliliter being a small unit of volume, or kilograms per liter, where we scale both of those units up by 1,000, and we get to 1 liter of volume and a mass in kilograms. When it comes to state of matter and density, in general, solids are more dense than liquids, which are more dense than gases. And this relates to our submicroscopic picture of these substances. Solids have particles packed very tightly together, so we have a lot of mass in a relatively small volume. In a gas, the particles are dispersed over a wide area. And one thing to note about gases is that density can vary over a wide range because the volume of a gas is not fixed. It's not intrinsic to the amount of substance. We can take a gas, for example, and compress it without gaining or losing any particles to increase the density simply by changing the volume, by lowering the volume, right? We have the same mass of gas particles inside this container, but the volume is smaller simply because we compressed it. One last thing to mention that I jumped over on this slide, density is a kind of conversion factor between mass and volume, right? It's the proportionality between mass and volume for a pure substance, so it allows us to calculate a mass from a measured volume, or vice versa. Density is an example of what we call an intensive property, a property of a substance that does not depend on the amount of stuff that's there. Extensive properties do depend on the amount of substance present. And intensive properties might be intrinsic to a substance, for example. Things like melting point, boiling point, these temperatures of phase transitions that don't care at all how much of the substance is there. They have the same value whether we're looking at 1 gram, 10 grams, 1,000 grams, etc. Right? Or intensive properties may refer to a standard amount of substance, and in chemistry, the most common standard is 1 mole or 1 gram. So we can talk about, for example, a heat capacity per gram or per mole. We can talk about a volume per mole. We can talk about a mass per mole. These are intensive properties. These per mole properties in particular are very special. They're what's known as molar properties. They have names like molar X, molar mass, molar volume, molar heat capacity, molar enthalpy of combustion, etc., etc., etc. And these molar quantities refer to 1 mole of a substance. So they are intensive in the sense that they don't vary based on the size of the particular sample we're looking at, but the reason they're intensive is because we're, in essence, dividing by moles, dividing by 1 mole to get units like grams per mole, liters per mole, joules per degree Celsius per mole, etc. So they're still intensive quantities. One such example of a molar quantity is the molar volume, and this is analogous to molar mass, but can be more convenient for liquids if we know it. since we can measure out liquids by volume and then count number of molecules using the molar volume. This is the volume occupied by 1 mole of a substance under specified conditions, and the conditions are important to specify. For example, the molar volume of a liquid is going to vary with temperature as the liquid expands or contracts with temperature. The typical units here are something like liters per mole. And one reason I wanted to bring up molar volume here is that the molar volume of an ideal gas at standard temperature and pressure has a fixed value. It's 22.4 liters per mole. We'll actually explain this and see where it comes from at the end of this unit when we talk about ways to calculate moles of gases from their measurable properties. For now, I just wanted to point out that this is a molar volume that you may have seen before, even in studies of gases. And molar volume is a quantity that, again, allows us to go from a measured volume to number of moles of particles in that substance, or vice versa. If we know a number of particles that we're shooting for, we can find the corresponding volume using the molar volume. I think it's also worth noting here that the molar volume can be determined from the molar mass and the mass density. Molar volume has units like, for example, liters per mole, and we already know that the molar mass has units like grams per mole, and the mass density has units like grams per liter. And so by taking the molar mass and dividing by the mass density, or multiplying by the reciprocal of the mass density in something like liters per gram, the gram units end up dividing out, and we end up with liters per mole, and this is exactly the molar volume. And so if we know the density and we know the molar mass, we can determine the molar volume of a substance. And like molar volume, density depends on conditions, temperature, pressure, that kind of thing. And so we do need to specify the conditions, at least implicitly, when we talk about density or molar volume.